we're back with Python Institute, this time lab number 3.1.2.15. I believe this is the final lab in Module 3. As it says here, as far as level of difficulty, medium, this is going to be kind of a doozy. So we'll see if we could take it step by step and work it from there. Again, utilize a while loop and verbally defined loops into actual Python code. So the scenario, 1937, German mathematician named Lothar Kolatz, I'm probably butchering that name, formulated an intriguing hypothesis which still remains unproven, which can be described in the following way. Taking a non-negative, non-zero integer number, name it C0. If it's even, evaluate C0 as C0 divided by 2. Otherwise, if it's odd, evaluate C0 as 3 times C0 plus 1. If C0 does not equal 1, then go back up to line number 2. Alright, hypothesis says that regardless of the initial value of C0, it will always return to 1. It'll always come out to 1 eventually. Of course, it's an extremely complex task to use a computer in order to prove a hypothesis for any natural number. Remember, we're talking everywhere from the number 1 up through pretty much infinity. But you can use Python to check some individual numbers. Maybe you'll find one that could disprove the hypothesis. Chances are, if we find one that disproves the hypothesis, it's our fault in our program, but we'll try it anyways. Alright, so write a program which reads one natural number and executes the above steps as long as C0 remains different from 1, not equal to 1. We'll also want to count the steps needed to achieve this goal. Your code should output all the intermediate values of C0 as well. Hint, the most important part of the problem is to transform Kolatz's idea into a while loop. This is the key to success. And then they give us some test data. So for instance, 15, and then here's our output data. In theory, every single iteration, of which there are 17, and you can see the last one comes out to 1. Kind of interesting that you start with 15, and then you work your way up, and eventually hit 16 before it finally starts working its way down to 1. Same thing with 16 and 1023, and we'll try some fun numbers in here. All right, so let's work through this and let's see what we can come up with. First off, on line number 1, it says any non-negative, non-zero integer. Well, non-negative, non-zero tells me, well, it's not 0, and it's not -1, and not -2, so pretty much anything which is greater than 0. Alright, so that should be the first thing to do, is to be able to say, hey, is this number greater than 0? Or specifically, if it is, we could say it the other way around, if it is less than 1, then we can give out some sort of an error message. Alright. So that's the first step. Next step, if it's even, evaluate C0 as C0 divided by 2. Well, we've been working enough with our programming skills here that we should be able to say C0 equals C0 divided by 2. That should be a piece of cake. That's line number 2. All right. Line number 3, otherwise, if it's odd, evaluate C0 as 3 times C0 plus 1. So C0 equals 3 times C0 plus 1. And then line number 4, if C0 is not equal to 1, skip to back up to 2. So that might mean up here we would have a while loop. While C0 not equal to 1. And then these guys would be indented to the while loop. Okay. So it seems like the only thing else that's there is some sort of an if statement to be able to choose between the two. Let's see. It said to keep track of our steps, so we'll have to have some sort of a variable called steps. So steps plus equals 1 in order to simply add 1 to the steps each and every single time. And then it also said to print out the value each and every single time. So we might also want a print C0. That might just be about everything that we need. So let's see if we can do that. So first thing we need to do is we need to get a number from the end user. And we can do that with a simple input statement. So a variable C0, it says to start with. And we'll start off with an input. Enter a number. Specifically says we want this to be an integer. So let's put an int around that. All right, then we say we want a non-negative, non-zero number. So I want to check to see if this is negative or 0. So I'll do an if statement. So if C0 is less than 1. To be less than 1, it would be 0 or negative. And let's go ahead and print out some sort of an error message. Print, use a non-negative, non-zero number. And now there's something you may not have seen before in a Python script. There is actually a way to be able to quit out of this script altogether. Previously, when we were working on functions, we talked about the break and the continue options. There's actually a command called exit, which allows us to exit out of Python altogether. So if I do this, then what will happen? If somebody types in a 0, for instance, it's going to come through, it's going to evaluate, yes, 0 is less than 1. It's going to print out the error message, and then it's just simply going to exit out of the script or quit the program. All right, so that's pretty much step number 1. Awesome. Let's see. So it did say that. Well, actually, let's start working on step number 2. Actually, step numbers 2 through 4. We said step number 4 is probably just going to be a while statement, and since 2 and 3 need to go inside of that while statement, we'll write the while statement first. So while C0 not equal to 1. All right. So let's see, is it even? So if C0, and now how do we figure out if something is even? Well, it turns out that there's actually the modulus function is really good for us. The modulus, that's the one that uses the % sign. Now how this works, remember, it's like long division from back when you were in school. If we have, for instance, the number 7, and we divide that by 2, 7 goes into 2 3 times. So 3 times 7 is 6. So 2 minus 6 is 2 minus, I got this backwards. Excuse me. 2, 7. There you go. 2 goes into 7. 6 times. 7 minus 6 is 1. So that means that is our remainder. So I can basically say if I have a remainder that is 1, it is odd. But if I have a remainder such as 2 modulus, say 26, 2 goes into 26 13 times. 13 times 2 is 26. So 26 minus 26 is 0. So if I have a remainder of 1, it is odd. If I have a remainder of 0, it is even. So the modulus tells me the remainder. So I should just be able to do C0 modulus 2. And then say, well, if that is equal to 0, then my result is even. So if it's even, then that means I want to evaluate this. So C0 equals C0 divided by 2. All right. Yeah, just make sure that that works out perfectly. Okay, so that's if it's even. Otherwise, if it's not even, then it's going to be odd. So I could just do an else. I could do a second modulus statement in there in order to evaluate whether it's fault or odd. But if it's not even, then it has to be odd. So if it's odd, then C0 equals that, which pretty much just copy and paste into Python. C0 equals 3 times C0 plus 1. Oops. And then it goes back up. Okay, so that is most of, actually, I think that is all of that right there. There is some additional steps, however, that it asked us to do. Let's see, it said that we wanted to print out all the intermediate values of C0. So that means down here in our while loop, after both the if and the else statement, we should print C0. So let's go ahead and do that. Print C0. And then it also said that we want to know how many steps it took. Let's see, we also want to count the number of steps needed for the goal and then should output all the results. In order to count all the outputs, or I'm sorry, the number of steps we're taking here, we need some sort of a counter. We need a variable that we can just simply add our counters into. So for that, I'm going to come up here before the while loop and I'm going to create a variable called steps. And I'll set steps equal to 0. Then inside the while loop, every time I print something out, I'm going to add 1 to the steps. For that, just steps plus equals 1. So that will just simply add 1 to steps every single time. And then outside of the while loop, it said we want to print those out. So I'm going to print out, just do a print command, total steps, total number of steps. And I'll put in the steps variable. So I think that might be just about it. Now, before I do this, I'm actually going to open up a different editor. Let me copy this. Control C. Just because we're going to have so much stuff in here that the outputs are going to roll off the screen pretty quickly. So I'm going to paste that in there, paste in my code. So that's exactly the same code we were just working on. And let's see. So we have test data on the left-hand side here of 15. Let's go ahead and run this script and see what happens. 15. All right, so it tells me steps 17. It looks about right. 46, 23, 70, 35, 106. So it looks about right, except for the fact that I'm doing a 0.0 at the end of all of these numbers. Now, remember, if I have just a plain number like this over here, that's considered an integer. If I have a decimal point included, however, it is considered a float. So somehow along this entire process, I'm converting an integer into a float. And you can kind of see it happens right after this first step. So if we look through here, see, we start off with 15. So we come in while C0 is greater than 1. If it's even, we do this. If it's odd, we do this. So it was odd. 15 is an odd number, so we do this right here, and we get the number 46. We then come back through here, and we do this process here. We do a division, and the next number is 23.0. So somehow during the division process, it takes our integer and converts it into a floating point number, into a float. Now there's two different ways we can do this. What we can do is instead of doing a simple divide, we could do the 2 divides, which means take the full integer output instead. And so now if I run it and I type in 15, now it returns the whole numbers. The other alternative would be to, instead of doing that, is actually to type in the int function around that code right there. And now if I run it, C0 divided by 2 returns back a floating point number, or float type, but then the int function converts it to an integer. These both do essentially the same thing. All right, so that seemed to work. Let's try the other numbers. So that was 15. The next one is 16. 4 steps, 8, 4, 2, 1. That seemed to be good. Let's try 1023. That should be 62 steps. And I'm not even going to worry about the contents. I'm just going to say, yes, that's 62 is the very last number. So that seemed to work. Let's see. Let's try about these non-negative, non-zero numbers. Let's type in a negative 42. And, oh, that did not do it. Negative 42, it is still going. So somehow it didn't like my exit statement. I'm actually curious. Let's try that one more time and I'll cancel it. So negative 42. I'll run it and then I'll cancel it very quickly. All right, so for some reason it's not scrolling up. I saw the fact that it did actually print out this message right here, but then it didn't seem to exit out properly. So my exit statement isn't quite working. What I could do instead is I could do an else, and then I could indent all of these guys. So it will do this or this. So now if I try it, negative 42, non-negative, non-zero number, and you know what, this print statement should probably be indented as well. Let's try that one more time. Use a non-negative, non-zero number. Otherwise, if I try just 42, then it works just fine. All right, now let's try just some random numbers. We'll try my second favorite random number out there, 8675309. That's right, we are trying Jenny. Does Jenny return something? Jenny returned in 212 steps. So we did not disprove his theorem, but we did create a script to be able to do something, to be able to help us prove it, prove or disprove it. Now, there's lots of different ways you could do this. This is just simply one way that I took. Definitely try whichever method works best for you.